I'm Alex Warner. I'm an undergraduate student at Georgia Tech. We're here at the Institute of Bioengineering and Biosciences. I'm just going to give a quick overview of my research area. So I focus on cancer, which is the second leading cause of death in the United States. And according to the American Cancer Society, 1 out of every 4 deaths in the United States will be a result of cancer. One of the problems with cancer is it's not a static process, but it's very dynamic. And one of the things involved in this is transport. Previous studies showed that lymph nodes and the lymphatic system were involved in transport, but it was under-characterized how. So my area of research focused on characterizing physical changes that will alter the transport in the lymphatic system. I'm just going to go through the different parts of my research real quick, and again, thank you to PURA for funding me this semester. So now we're in the mechanical testing room here at Georgia Tech, and this is where the first place we start to categorize the different physical properties of the lymph nodes. So what I have behind me is a machine here that helps me do the mechanical testing. And in my hand I'm holding a 1 Newton load cell, and we use a spherical indenter to push the lymph node to 10% strain. And with the different lymph node sizes, what we do is we measure the thickness, and that's how we determine this calculation. And then what we'll do is go back through, and this helps us determine the elastic modulus, which gives us an insight into physical properties of the lymph node. So after the lymph node samples undergo mechanical testing, they're brought here to the histology center at Georgia Tech. Additionally, at this time we add in our cancer samples on the tumor itself and the skin control samples as well. So after they're processed, they go right here into our paraffin bath, which will basically allow us to block them. Like this here, we'll have an example of one I've done. This is a tumor sample, and it's just blocked in there. This will allow us to cut different samples from the sample itself. We'll bring it over here to the microtome, where I can cut 5 micron thick samples that will be mounted on slides. And then once the slides are done, they're brought over here. They're allowed to dry overnight because if any water's on the sample, it'll ruin it. To our autostainer. The autostainer will run a program that will remove the paraffin and leave just the sample itself, so we can perform histological staining. So after the samples have undergone histological staining, they go up here where they can be imaged. We use this bright field microscope right here to look at our images. And then on the computer, we'll take 4x, 10x, and 20x magnifications. This just allows us to look at our samples a little more closely. So this is an example of the lymph node. We do this for the tumor samples and then the skin samples as well, which are our control. And again, I'd like to just thank PURA for the funding and wish they continue to support the biosciences and bioengineering in their future funding considerations.